Okay, so we are going to start in our flip book on the trapezoids page. So if you will flip to the tab for trapezoids. All right, on this page, I tell you where to copy everything down. So on the left side of the flap, that's where you're going to copy all of this information down. Okay, so you might want to divide it down the middle like we previously have. All this needs to be copied on the left side. All right, so. There it goes. Okay, so first are properties of a trapezoid. The first is that one pair of parallel sides is going to be called the bases of the trapezoid. The second is that the non-parallel sides are called legs. So these two, top and bottom, that run parallel to one another are referred to as the bases. And then those two on the outside edges that are not parallel lines are what we call the legs of the trapezoid. In trapezoids, consecutive angles between the parallel lines are supplementary. So between the parallel lines would mean this angle and this angle, or this one and this one. Those two angle pairs are supplementary. So they have to be between the parallel lines to be a supplementary pair. And consecutive, as we know, means the ones beside each other, right? So it could be this set and this set, but it wouldn't be these two on the same base, or those two on the same base, okay? And then you might want to draw this picture off to the side and label them so you know what we're referring to as our bases and legs. Okay, and so whenever we say the ones that are supplementary, we're talking about X and Y, like I said, and W and Z. So one from the top base and one from the bottom base that are consecutive, not opposite, but consecutive. All right? All right, next we're going to talk about a specific type of trapezoid. So then the type of trapezoid we're going to talk about now is an isosceles trapezoid. It's similar to having triangles, and then we have special types of triangles, right? So an isosceles trapezoid is similar to an isosceles triangle. But before we do that, I want you to use those rules that we just discussed, so these ones that we just wrote down, to work on the first part of number 1 and the third part of number 2 on that classwork assignment that you have in front of you there. So work on the first part of number 1 and the third part of number 2, using what we have just discussed. I'll give you just a second to fill in those 2 blanks. So the first blank on number 1, third blank on number 2. All right, so on number 1, the first blank asks for the measure of angle GFJ. So that's angle F. Well, according to our rules, what do we know about the angle F they're asking for and angle J, the one they gave me? Supplementary. So what does angle F have to be? Okay. On number 2, we know angle J is 68. And the third blank, the one they asked you to fill in, is angle GHJ, so angle H. What do we know about angle J and angle H? Supplementary. So what's angle H going to be? Very good. All right. So now we're going to fill in some more in our flip book about isosceles trapezoids. Okay, so we got a little picture over here. It's still going to have those parallel bases, and then the non-parallel sides are the legs. In an isosceles trapezoid, kind of like in an isosceles triangle, your 2 legs are going to be congruent. what this does is create congruent base angles, just like it does in an isosceles triangle, right? So those two legs are going to be congruent, creating our base angles to be congruent as well. So that would also mean we have congruent base angles on base 1 as well. So we've got two sets of congruent base angles. And because it's a trapezoid, we still know that the consecutive angles between the two parallel lines are still supplementary. So we've got base angles on the top and base angles on the bottom there. Okay. The second property of our isosceles trapezoid is that the diagonals are congruent. So if I was to draw a diagonal from this base angle in blue to this one in red, and from this one in blue to this one in red, they're going to end up being congruent in size. And if those diagonals are congruent in size, it's going to split it into some congruent parts, right? But because of the shape here, the pieces that are going to end up being congruent are the two pieces on the bottom halves of the diagonal and the two pieces on the top of the diagonal. Okay, so the entire diagonal from here to here and from here to here is equal, but that also ends up telling us that this part down here and these two parts up here are congruent. So now, because of those diagonals crossing, we have created two similar isosceles triangles. What does similar mean? Proportional, right? They're the same shape, but they're not the same size, right? So they're identical in size, identical in shape, but different in size because they grow or shrink by some scale factor. So each side is proportional to its corresponding side by some scale factor. All right, so isosceles have all the same properties as a trapezoid, but a couple additional of its own. One, that the legs are congruent, and if the legs are congruent, we obviously know the base angles are going to be congruent. And second, that the diagonals are congruent, which is going to make these two and these two pieces of the diagonals congruent. So could I say the diagonals bisect each other here? Is that true? No, those lines are not cut in half, right? This part and this part are not the same size. So that property does not apply to our trapezoids like it did for our parallelograms, rectangles, squares, and rhombi. All right? Okay, so we've got our information about isosceles, so now you can finish out numbers 1 and 2. You can fill in the remainder of those blanks, since both of those are isosceles trapezoids, and you can answer number 3 as well. So I'm going to give you a second to do that. All right, so on number 1, we had already filled in the first blank. We said angle GFJ was 70, so angle F. The second blank asks for angle FGH, angle G. How many degrees is angle G?
65.
How many degrees is angle G on number 1? 70. And how many degrees is angle GHJ? 110. So they should be congruent to the other base angles. On number 2, we already filled in the last blank. What about that first blank? Angle GFJ. How much is that one? 68. And angle FGH? 112, right? Congruent to the one that we already found. Okay. On number 3, they asked for angle FGA, and we are given the information that angle GAE, so angle A, is 4x minus 25, and angle AEF, or angle E, is 3x plus 10. So if we're going to find FGA, then we have to first find x. So what do we do with the two angles they gave us so we can solve for x? Very good. We set them equal to each other because those are supposed to be congruent base angles, right? So what do we get for x? 35. So I could plug that in to find angle A or E, right? And what do we get for the measure of angles A and E? 115, right? And they want angle G. Well, what do I know about angle A and angle G? Supplementary, so what is angle G? Very good. All right. The last thing we're going to fill in on this page is about our mid-segments of a trapezoid. So the mid-segment, as you can see in this picture, is going to be a line drawn between the two legs. Okay, and it's going to split your legs into two congruent pieces. So it's going to go from the midpoint of this side to the midpoint of that side. And you can find the mid-segment by averaging the two bases. So it should be an average length of the top, of the top and the bottom base. So if they told you the length of base 1 was 6, and they told you that the length of base 2 was 8, you would just add the two together and divide by 2 to find the length of your mid-segment. You'll know that it's a mid-segment because you can see it splits the two legs into congruent pieces. So meaning it hits midpoint to midpoint. All right, so now that we know what a mid-segment is, let's go back to our paper. You should now be able to answer numbers 4 and 5. And I want you to attempt setting up 6 and 7. What did you say? Yes, it is. Yeah, thank you. So on number 5, I know it kind of cut off that first number. It's 64 on number 5. All right, so on number 4, what did we set up to solve for MN? All right. We added the 17 and 21, multiply by a half, or divide by 2. And then same thing for number 5, right? Okay, on numbers 6 and 7, on those two, we're asked to solve for a variable, right? Okay, well, I still would go about setting them up the same way, right? So for number 6, are my two bases? Right. So I'll have 10 plus 44. And what am I supposed to do with those after I add them together? Divide by 2 or multiply by half. Good. And that's supposed to give me the mid-segment, right? And what did they say the mid-segment was on number 6? So I'm going to have 2x minus 1 is equal to this, and then we just solve, kind of like we did when we had those formulas for our measure of arcs on our circles and exterior angles. Okay, and we do something very similar for number 7 as well, right? Okay. All right, so on the right side of your trapezoid flap, so we divided it down the middle, these are the ways that you can prove that you have an isosceles trapezoid. Okay, so even if you're not finished with the questions on the paper, you need to copy this down in your flip book. It says that these are the ways we prove we have an isosceles trapezoid. Okay, so we have some theorems. Okay, our first theorem is that if base angles are congruent, then you know you have an isosceles trapezoid. So if you can prove both sets of your base angles are congruent, that's enough to say that you have an isosceles trapezoid. The second is a trapezoid is isosceles if and only if the diagonals are congruent. So if you can prove the entire length of the diagonals are congruent, that's enough to prove that you have an isosceles. Okay? All right, and then the last way is that the mid-segment is 1/2 the sum of the bases. In other words, that formula that we just talked about. Mid-segment equals 1/2 times base 1 plus base 2. So basically, all three of the properties that we wrote down for an isosceles, if you can prove any of them to be true, then that means you have an isosceles. And it shouldn't be too hard for us to remember what the properties of an isosceles trapezoid are, since they're so similar to that of an isosceles triangle. Really, the only additional one that we didn't typically see in our triangles is this right here, right? And number 2, the diagonals are what were already there, right, in the triangle itself. Okay, now we're going to draw on the top half some examples. Okay, so go ahead and divide your top half of that flap down the middle. All right, so on the top half of the flap, you don't need to write the sentence, but you do need to draw the picture. Basically, you've got 3 trapezoids stacked on top of each other, and they're not isosceles, right? Because the legs are not congruent. So on the top one, this leg is a little more longer and slanted. On the second one, it flips directions, and then on the third one, it flips directions again. So just stack 3 trapezoids on top of each other. And for the trapezoid on the top, we know the very top base, base 1 of that green trapezoid, has a length of 10. And its vertices are G, H, E, and K. And you need to also draw in this mid-segment here from F to J. All right, for that second one, we weren't given base 1 or base 2, but we already know E and K are shared vertices with the one above, and then add in C and M for your vertices at the bottom of that second trapezoid, and go ahead and draw in this mid-segment here from D to L, and we know that DL is going to have a length of 90. And then for that last trapezoid, you're going to add the vertices A and P. And we know that the bottom base has a length of 200. And this mid-segment from B to N has a length of 160. All right, so it says that we are going to use the information above to find FJ. All right, so in order to find FJ is a mid-segment, I need to know both of the bases, right? And right now we only know one. So I'm going to have to work backwards in order to find the base EK. So we're going to have to start with the bottom trapezoid because that's the only trapezoid I have two pieces for, right? Okay, so on this bottom trapezoid, I know the base and I know the mid-segment. So I'm going to use that mid-segment formula to help me find CM, the other base. So remember, we would add the two bases, which would be CM and 200, right? And divide by 2 and set it equal to the mid-segment. So that's what we're going to do first. Set that up. We've got 160, our mid-segment, is equal to half 200, this base, plus CM, the other base, in that largest trapezoid. All right, so what would we do to get rid of that fraction, the 1/2? Right. So when we multiply by 2, we're going to get 320 is equal to our 200 plus CM, right? And then what would be our last step to solve for CM? Right. So 320 minus 200 leaves us with a length of 120 for CM. Okay, so now over here in my picture, I can label CM, this base, has a length of 120. Okay? And now we have two pieces for that middle trapezoid, right? The same two pieces, one base and one mid-segment. So we can set up the same thing again. So this time, our mid-segment is 90. One of our bases is 120, and the other one, EK, we don't know. So that's what we're solving for. Again, how am I going to get rid of that fraction? Multiply by 2. Good. So now I have 180 equals 120 plus EK. So what's EK going to be? 60. Good. All right, and now that I know EK is 60, I can also label that on my trapezoid over here. And now we can finally find the piece they asked for, which was FJ, right? Is FJ a base or a mid-segment? Mid-segment. So FJ will go where the 90 and the 160 went over here. Now I'm going to have two real numbers to plug in over here. So once we substitute all that information in, we've got FJ is equal to 1/2 10 plus 60. So order of operations, we'd add first, right, and then multiply because the addition is in the parentheses. So we would add and get 70, and then we half it, and FJ is going to be what? 35. Good. Okay. All right, and now we got one more picture we're going to copy over on the other half of our top flap. So this was on the left-hand side. We're going to copy this next picture onto the right-hand side. Okay, this next one is not near as large. It's just an isosceles trapezoid all by itself, just the one. Okay, so you're going to copy this picture onto the right-hand side. Again, you don't need to copy down the sentence. We're just going to label all of these pieces. So we've got that the vertices are EZIO. They tell you EO, which is this diagonal, is 4x plus 6. And IZ, the other diagonal, is 10x minus 18. And we're going to find x and the length of both of those pieces. Well, if this is an isosceles trapezoid, what do I know about the diagonals? What was the property we wrote down for diagonals in an isosceles trapezoid? So that's not what we wrote down. The diagonals are what? Congruent. So if they gave me this and they gave me this, what am I going to do with the two pieces? All right, set them equal to each other. So since the diagonals are congruent, I set these two equal to each other. We just substituted in what E, O, and I, Z were. All right, and then we're going to solve. So what do we do first? So we're going to move all those x's to the same side and all the constants to the same side. Good. All right. And so what are we going to get for x? Good. All right, but then they also asked us to find EO and IZ. So now what would I do with that 4? Right. So I substitute that into the two pieces they gave us. EO was 4x plus 6, so I just plug in 4 for x. And IZ was 10x minus 18, so we substitute in the 4 for x there. And just like our property said, the two diagonals are equal or congruent. All right, next we're going to talk about our kites. So if you want to flip to the tab for kites. So these are going to be all the properties of our kites. You don't have to divide this one in half because everything for the bottom half is all going to fit on this slide. Okay. So this is all of our information for kites. So we'll do the information on this slide, and then we'll do examples on the top half in just a second. All right, so first, our first property of a kite is that it has two pairs of adjacent congruent sides. What does adjacent mean? Right. So those two are right next to each other, and they're congruent. And these two are right next to each other, so they're congruent. Okay, so this is going to create a triangle ABD in this top half here. If I drew a line right here, and CBD in the bottom half. So we now have two what kind of triangles? Isosceles again. Very good. All right, so the angles at B and D, what do you think is going to happen to angles B and D when we draw that line in to create those isosceles triangles? Going to bisect it. Very good. All right. So in the top half, like you guys said, we had an isosceles triangle, so it has two congruent base angles, and same thing in the bottom. Oops, sorry. And we have two congruent there in the bottom as well. So we have an isosceles triangle down here with two congruent sides, two congruent base angles, and the same in the top. Two congruent sides, two congruent base angles. All right? So with that information, if you'll flip your worksheet over onto the back, we're going to look at a few problems there at the top to see if we can find the missing angles, now knowing this information. All right, so see if you can complete 8, 9, and 10 there at the top. I'll give you just a second to do that. Keep in mind, guys, that we don't know what the measures of the blue and red marks are, but whatever they are for D, they're the same for B, right? So angles B and D are what? Huh? Congruent, right. So on number 8, what's the measure of angle K? 88. On number 9, we're looking for angle K. K and M are in the same place as they were in the first picture. So if I know J and L are 60 and 50, what could I do to figure out M and K?
Yeah.
We add them together and subtract from what? So that's going to give us 250. And what do I know about M and K? They're congruent, so I just split it evenly, right? Okay, on number 10, they want to know the value of x. What do I know about the angle labeled 2x and the angle labeled 111? Right, so I just set them equal to each other and solve, right? Okay. All right. They have an angle sum of 360, so subtract the ones you know. All right. So back to our flip book. The second thing you need to write down on that flap is that the diagonals are perpendicular. And what does diagonals being perpendicular mean? Very good. So it asks then, what does the line segment AC do to angle BAD? So what did that line segment AC do to angle A? And what did AC do to angle C? So now we can say that E is the blank of BD. What is E on line segment BD? No, what is point E? It's a what? No, the mid-segment's a line. What is point E? Midpoint. Very good. All right, so E is the midpoint of BD. All right, third thing is that it has one pair of opposite angles that are congruent. All right, so we know that we've got the two pairs of adjacent congruent sides, so the two short sides will be the same size, and the two longer sides will be the same size. We also know that the diagonals are perpendicular, meaning their intersection is going to have right angles. And we know that angle A and C, in this specific case, are going to be bisected by the segment. And that E ends up being the midpoint of BD. All this is useful information depending on which pieces they give you, right? So see what you are going to need to be solving for. All right, and we also have two examples. So in the top half of your flap, if you'll divide that down the middle, these are the two pictures you're going to draw up there. Again, no need to copy the sentences above, just draw the pictures. So for this first type, I've got AD and CD is what we're looking for, while AC has a length of 21. So in the picture, they went ahead and marked the congruent adjacent sides for us, right? And then they told us from A to E had a length of 6, and BA has a length of 10. So I'm looking first for AD. Well, AD is this segment over here. How long should AD be? 10. Okay, we also know that we have these right angles around here. So when I go to look for CD, I end up having all of these right triangles, right, where we know some information already. If I know this piece is 10 and this piece is 6, what could I do to find BE? Pythagorean theorem, right? And then I'll know a piece of this right triangle as well. Okay, so like you guys said, we could do Pythagorean theorem to find BE. So we're going to end up with BE must be how long? 8. Good. All right, and because we said E was the midpoint of that line, if BE is 8, what is DE? Also 8, okay? Oops, sorry. Got ahead of myself there. And then they said AC from here to here is 21, right? And we know from A to E is 6. So how could I find just EC? Right, subtract. So now I know that EC is 15. Now what could I do to find BC or CD on the outside edge? Back right there. All right. So what's C going to be, or C squared, the missing piece going to be? 17. Good. And that's the other piece they asked for. So if these pieces are 10 and 17, we know those pieces are 10 and 17. All right, and then on that second picture, our job is just to find all of the missing angles. All right, well, you guys already told me that you knew that this angle down here and this angle up here gets what by that line? Bisected. So if this part's 23, I already know this part will also be 23. Okay? And we also said that because of these markings, we have two isosceles triangles. So in isosceles triangles, not only are the sides congruent, the base angles are also congruent. So if this is 18, then this piece must also be 18. And what do I know all the angles right here at the intersection of the diagonals are? 90. Okay, so we've already got some information without even having to solve. We've got our right angles. We know that angle is going to be 23. Oops, sorry. And we know that this angle is going to be 18. So in both of these, I now have a 23 and a 90. What could we do to solve for that missing angle? Right. Just subtract and get that piece that's missing. So it's going to be 67. And if this angle is 67, what's this one? 67, right? And we can do the same thing for these over here, right? We've got an 18 and a 90. We can just subtract to figure out what's missing. Both of those must be 72. All right? And the remainder of the questions on the assignment are for you to finish, and we'll grade this tomorrow, okay?